The webinar today is to explore the question, how can learner corpora help us better understand second language development? And I do that based on a case study that looks at learner phraseology development, and more specifically, the development of what I call VACs. You'll hear that a lot throughout the talk, just to save time, because it stands for a pretty long phrase, verb, argument, constructions. And I'll tell you in a minute what those are. So I'm interested in how language develops in second language learners of English in this case, and how we can use corpus tools and corpus methods combined with some natural language processing tools and techniques to trace that development and to figure out what do we need to know about learner language development. So what can corpus linguistics tell us about second language acquisition? This question here is actually the title of a forthcoming chapter I wrote with James Garner, and which is going to be published in the second edition of the Routledge Handbook of Corpus Linguistics, edited by Anne O'Keefe and Mike McCarthy. And so what we argue, James and I, in this chapter is that corpus linguistics and particularly learner corpus research, LCR, have a lot to offer to SLA. Because when you think about SLA, what is SLA and what do SLA scholars try to better understand? Well, it's the process of second language acquisition. It's developmental stages, the role of input learners get, analyzing the output, looking at L1 effects, things like that. Of course, the list goes on, but I think for me, the focus, one particular focus is to help us to better understand what the process of SLA looks like. And I'm quoting two colleagues here, two corpus colleagues who say that much of SLA research has traditionally relied on elicited experimental data while disfavoring natural language data. And that is potentially a problem, because we want to study large amounts of data that are naturally, have been naturally produced. And I would agree here with Granger, who says that research based on corpora can actually lay claim to greater representativeness than previous SLA studies that may have been based exclusively on grammaticality judgment tests or experimental data. So when you think about LCR, learner corpus research for second language acquisition, I would say that it can benefit especially from the type of research that highlights the process rather than the product of SLA. And that is potentially one reason, I think, for the lack of integration of SLA and corpus research is that a lot of our research based on learner corpora looks at the outcome, looks at the product of learner production data at an advanced proficiency level, and not so much across the developmental stages of learners. So what we need to really focus on the process, I think, is focus more on three types of learner corpora that I would label longitudinal, cross-sectional, and pseudo or quasi-longitudinal. The longitudinal type I tried to illustrate in this plot here on the left, where you have data collected from the same learner or learners across different proficiency levels and at different points in time. So you would track a learner's progress throughout the course of time, in terms of beginner, intermediate, and advanced levels of study. That requires a lot of time, of course, to collect data at multiple points in time. To speed things up in terms of data collection, very often we don't have that time for a project to just collect data from the same learners over several years. You can collect or compile a so-called cross-sectional corpus, where you collect data from different learner groups at different levels, but you can collect that data at one point in time. So I could go right now and collect texts written by students at different levels in an intensive English program or something right? So pseudo-longitudinal is somewhere in between, between the other two, where you would still collect data at different points in time, but and you may have the same learners in those different cohorts, but you also have some learners that come in or drop out. So for me, it's somewhere in between. It's not a strictly speaking, a longitudinal corpus, even though you collect at different data points, different points in time, but it's also not cross-sectional. So what I'm going to illustrate this with a specific corpus that I used for this project. So I'm going to focus on a case study that uses such a pseudo-longitudinal corpus to track second language learner development of these verb argument constructions. So what is a construction? Why are those important when we look at language acquisition? I follow Goldberg here in defining constructions as conventionalized pairings of form and meaning that are entrenched in the speaker's mind. And Goldberg would argue, and construction grammarians would argue, that constructions exist at various levels of complexity. So anything from a morpheme up to a idiom or syntactic frame, grammatical frame, is a construction as long as you have a stable meaning associated with a form. And VACs are particularly important because they form the core of a sentence. So if you think of a ditransitive construction, as in, she gave me a box of chocolates, right? Then you have the verb give as a central element that governs the structure of this sentence. Right? So the construction is an important element here. And there's been a lot of usage-based language acquisition research, both within L1, first language acquisition, and second language acquisition, that has demonstrated that we actually acquire a language by learning constructions, right? We pick up on those form meaning pairings at different levels of complexity and develop a network of constructions, or a constructicon, like a lexicon of constructions, as we do that. And I've been lucky to have been involved in extensive research on VAC acquisition and use, together with Nick Ellis and Matt O'Donnell and other colleagues. And this research was based on both L1 and L2 corpora and psycholinguistic data. Just going to give you a few findings from that larger project, where we looked at VACs in the BNC and in learner corpora and psycholinguistic experiments, and found that those constructions are very much Zipfian in their type token distributions. And you see a Zipfian distribution plot here on the right for the construction verb about N. So talk about something, think about something, right? So Zipfian essentially means that you have one or two items in this construction here, verbs that occur very, very frequently, and then a lot of verbs that occur maybe only once or twice. So it's the power law distribution, where you see here in this plot that think is one of the most entrenched verbs in this construction, and then if you look further up on the left, theorize about is not very frequent, right? So this allows us to, or this contributes to learning, having this type of skewed distribution, Zipfian distribution. We also found that these constructions are selective in their verb form occupancy and coherent in their semantics. We found that both L1, L1 and advanced L2 speakers have knowledge of constructions. They know which verbs are good fit for a construction. And this knowledge is influenced by frequency in lots of ways. Frequency of the verb in a construction. This was based on data from the British National Corpus, 100 million words of usage. It's based on the faithfulness of verbs to particular constructions and the centrality of verb meaning in the construction semantic network of usage. We have a lot of findings, so we wrote a book to summarize everything, and if you're interested, this is what it looks like. What I'm doing in my ongoing research in the study I'm presenting on today is essentially connecting back to the VACnet project, but going beyond it by examining the development of L2 learner knowledge, development of constructions. And I'm also not looking at just specific types of constructions, like I think most of the ones we looked at previously are verbs followed by prepositional phrases, so verb, preposition, noun, phrase. So I'm approaching this a little more comprehensively, more systematically here by extracting all the verb constructions, or trying to extract all verb constructions from different levels of proficiency. So the 4 questions I'm going to touch upon today in my talk, and I'll go pretty quickly through some of the results, but hopefully we have time to get back to things you're curious about, are the following 4 here. I'll start with a question about first VACs. So which constructions develop or emerge first at beginning level of English language instruction? And then how does that VAC repertoire develop across proficiency levels? So what verb constructions do we find early on, and then how does that set of constructions develop in terms of types and tokens? Also, how does the distribution of verbs in constructions develop across proficiency levels? So if a learner acquires a construction, do they know which verbs to use it with, and how does the verb repertoire change over time and proficiency? And then another question I'm interested in as a phraseologist is the role of formulaic sequences in this L2 acquisition. Do formulaic sequences contribute, and if so, in what way, to our acquisition of verb argument constructions? So of course, there's been previous research on construction development, but there's still, I think, a pretty substantial research gap that I'm hoping to help fill here. We have a lot of evidence from first language acquisition research that indicates that children move from simple formulaic chunks or constructions to more complex and variable ones. And also very similar evidence actually from SLA research that a learner's construction inventory starts from a smaller set of fixed sequences and then grows in complexity, abstractness, and productivity. And those were kind of the guiding or studies that are guiding my research. But I see 2 problems with those studies. They're very thorough and very rich in terms of the data they use, but the data is usually collected from a very small number of learners. Very often it's just one learner, so it's a truly longitudinal data set following one learner and recording all of their utterances or written output over a certain period of time. But I think we probably need to look at more data to be able to generalize these findings. And then another problem is that scholars have looked at, because you have to start somewhere, right? So scholars have looked at a small number of VACs, and we need, I think, a more comprehensive approach that looks at the constructicon, verb constructicon as a whole, if possible. So my goal here is to back up existing studies with more representative evidence. And to do so, I extracted learner writing from EFCAMDAT, that's the Education First Cambridge Open Language Database, and it consists of student writing produced as part of EF's English online class or online school called English Town. And it's a great resource for learner corpus researchers because it provides a lot more data than any other freely available corpus does. It was not initially compiled as a learner corpus, so we don't have a lot of the information we would like to have about each learner in terms of language background. But it is big, and it does, another advantage is that students are placed into 16 proficiency levels as they join English Town, and these 16 proficiency levels correspond to the CEFR levels, the Common European Framework of Reference for Language Learning, A1 through C2. I put C2 in parentheses here because there's very little data from learners at this high advanced proficiency level. So what the results I'm going to show you today are based on are two subsets, essentially, well, two subsets, but I'll focus mostly on the L1 German learner data. About 2.8 million words produced by learners, English language learners in Germany, and 3.2 million words by English language learners in Mexico. So 5 levels times 2 L1s gives me 10 subcorpora altogether. And I extracted constructions from these 10 subcorpora with the help of NLP technology and with the help of a graduate from our PhD program, Christopher Kyle. So we exhaustively retrieved verbs and the constructions they occur in these subsets using syntactic annotation and natural language processing techniques, and then which allowed us to compile frequency profiles for all the main verb lemmas and constructions and verb construction combinations. So the result of this extraction process is a set of databases or constructica for each L1 and level. So I have 10 of those construction databases for each of the 10 EFCAMDAT subsets that I can now look at and extract more specific data from. So I can extract lists of the most frequent constructions at each level, the most frequent verb lemma construction combinations, and for each construction I can look at the most frequent verbs, the most statistically entrenched or associated verbs using association strength measures like delta P or faithfulness. Right? So this is just a snippet to illustrate what this looks like from the construction database for the German B1 level data set. And this is a lemma construction combination here. So you see that the top, the third most frequent combination of a verb and a construction is have in a transitive construction. So these are the construction labels you see are based on the Stanford parser categories. And then I can also pull out examples from the database that illustrate the use of all these constructions and verb lemma combinations. So here are two examples that illustrate this particular construction at low intermediate level in the German learner data set. The solution to ease your suffering is one of them. To address the fourth research question about the importance of formulaic sequences in construction acquisition, we also carried out a cluster extraction, and I did that with the help of a former PhD student and 2 former undergraduate students. So we extracted word clusters of different lengths, so essentially n-grams around all lemma forms of the 50 most frequent verbs, and saved these lists based or sorted by frequency and sorted by MI score, strength of association measure. I have a lot of lists, about 6,400 lists, and it takes a while to look at all of them, but I've looked at, I don't know, a couple hundred so far to look at just the most frequent verbs and get a sense of how do they develop in terms of clusters that may then turn into constructions. Right? So I'm going to share some results with you based on different forms of the verb make. But first of all, before we look at research question 2, let's start with research question 1. What are the first VACs in L2 learner English? So this is based on the German learner data we have here. Okay, so the top 10 first VACs in German A1, in the German A1 data set, low beginners, beginning learners of English. If you look at that list, highlighted some interesting elements here. We see that among the first VACs, we have a lot of copula B constructions. We have simple transitive constructions, simple intransitive constructions. So they're pretty short, those constructions, right? And then also verbs followed by a specific preposition. And if you go further down on this list, there are a few more. I highlighted one that is essentially nominal subject followed by a verb followed by in. Live in is very, very frequent. I guess learners describe where they're from, where they live. You also see in these examples there's some interesting German L1 transfer effects on word order number 3. I have on Wednesday sport. Actually, that spelling of Wednesday looks much more appropriate than the actual spelling, but it's, of course, that's not what we use. But that would, that follows German word order. I have on Wednesday sport is how you would say it in German. And there is an Ute in this database, apparently. That wasn't me writing that text. So, so this is some of the first VACs that emerge as learners start to write texts in a foreign language. What this graph shows is essentially addressing research question 2, the development of the VAC repertoire over time or with proficiency levels. And these are normalized VAC type frequencies that I plotted here. So we see an overall increase in growth in learners' construction repertoire, which is what we would like to see, of course. Now, we can compare the top 10 VACs across different levels, right? So I picked 2 levels to compare here, the lowest proficiency level A1 and then the upper intermediate level B2. And I highlighted in bold, I highlighted the verbs that are shared. So 7 of the top 10 VACs are shared between these 2 levels. With different normed frequencies, though. So the same constructions would, of course, not disappear just because they were learned early, that they're still used. We still have ditransitive or simple transitive, intransitive constructions at the higher level. But the interesting thing is that we have more complex construction. Again, we have this specific preposition construction here that doesn't occur very frequently at the B2 level. And if we look at the top 20, there are a few more with preposition at, and I think over. And then more constructions get longer pretty quickly if you look further down in the B2 frequency list. And what I found interesting here and what I'm looking at right now in my analyses are constructions that contain modal verbs, which seem a lot more frequent at the higher levels, at the higher proficiency levels, and either not there or very, very infrequent at A1 and A2 levels. So we can also look at the top lemma VAC constructions, again, across proficiency levels. So that would give us a sense of which combinations of verbs and constructions are the most frequent ones. And again, I have this juxtaposition here of data from A1 and the B2 levels. We have 3 that are shared, 2 copula B constructions and transitive construction with have. And then at A1 level, we see constructions with high frequency verbs, exclusively high frequency verbs among the top 10. Verbs like be and live and have, see. Whereas at the B2 level, we also have constructions with lower frequency verbs like apply or find or observe. Now, to see if the predictability of specific constructions changed across levels and how verb distributions developed, I calculated normalized entropy scores. If you're not familiar with this measure, it's a measure of uncertainty of a probability distribution. In my case, in this study, a measure of how certain or how predictable the distribution of verb types is in constructions across levels and across L1s. And entropy scores range from 0 to 1, values closer to 1 indicate that you have a more even and unpredictable distribution, and values closer to 0 indicate that your distribution is more skewed and usually Zipfian, that you have 1 or 2 verbs that are very, very frequent, so you can almost predict what verb to use in this construction, which is helpful for learners. I would think that those constructions are easier to acquire if you know, oh, as long as I use have here, I'm good. This is going to be safe. Then the entropy value can indicate whether or not you have that kind of distribution. So it's more predictable. You may wonder why I'm not just using type token ratios to look at the productivity and the variability in the slot in a construction. And I'm going to illustrate why. Type token ratios are very sensitive to Zipfian distributions, Zipfian frequency distributions. And so if you look at these two hypothetical distributions of 5 verbs in a construction, and I borrowed this from a publication by Ghys and Ellis, you see that both distributions, both these are made up, so both hypothetical verb distributions have the same number of types. We have 5 different verbs. On the left, each verb occurs 246 times. So we also have the same 5 verbs on the right. And we have the same number of tokens if you add up all those numbers above the bars. We have 1,229 instances of this construction in both plots, but of course the distributions are very different, and I would argue that it would be much easier to teach the construction on the right that is highly predictable, so you know what verb to use here, whereas on the left, and you see the that's a score of H norm of 1, and here it's a much small, very close to 0 actually, 0.016. They're very different. The plot on the left shows that you cannot predict which verb is going to be next in this construction, right? So that's why entropy is a useful measure for this. Here are some results for 2 high frequency constructions in my data set. The blue line represents entropy scores for what I call the modal VAC. It's essentially subject, modal verb, verb, direct object. I can speak English, right? That would be an example. And the orange line is represents findings for a transitive construction, subject, verb, direct object. So for both, you see that with proficiency, the normed entropy scores go up. They do get closer to an L1 reference point. So I used COCA, the academic subset of the Corpus of Contemporary American English, as a reference database, or as a reference data set. So that is good, right? With increasing proficiency, learners get closer to scores, to normalized entropy scores we would find for the same constructions in L1 data. But I had just finished a study with James Garner where we looked at VACs in subsets of the Trinity-Lancaster corpus of spoken learner English, again, across proficiency levels. And we found the opposite trend. So for these constructions here, the entropy scores go down with increase in proficiency. And again, they get closer to a native norm or an L1 norm, but it's the opposite trend here. So I guess this indicates that with entropy, you can't just say, oh, higher entropy or lower entropy is better. You need a reference data set. And what I think is going on here is that these two constructions that are plotted on this slide are very general and potentially what falls under subject, verb, direct, object is a set of constructions rather than a single one with one meaning. Whereas what we have here, so of course they would be less predictable. They can accommodate a lot of different verbs with varying frequencies. Whereas the ones here are very specific in terms of semantics and verb form occupancy in the V slot. So we want to move closer to lower entropy scores in this case. Now, to see how verbs in VACs develop, I also calculated correlations between verb lists from 2 corpora at a time, and that allows me to systematically compare verb in VAC distributions for learner groups across proficiency levels, across L1s, and also in comparison with native speaker usage. And I'll show you some R values. So 0 would be no correlation, 1 would be a perfect correlation with C values in between. And I'm also going to show you some scatter plots that visualize verb distributions. Okay, so these are pairwise comparisons, learners across different levels, right? And what you see here, and that's for, again, for the same 2 constructions. Those are the verbs that are used in the transitive construction and the modal construction. And what you see here is that the R values are particularly high for adjacent levels and lower for non-adjacent levels. So if you compare the verbs that A1 and A2 learners use with A1 and C1, you find more overlap, which is a good thing, right? So this suggests that there's more similarity between learners that are close to each other in proficiency than learners who are not close to each other. So there's a development towards more variety in verb use at higher levels of proficiency. So we can also visualize these correlations rather than just having the R value. We can plot the verbs that contributed to this R value and see, well, which of these data sets or which of these learner groups uses this construction more productively and which verbs do they use more frequently than the other group. So that's what you get when you create these scatter plots. You can see that in this case I plotted A1 and B2 learners against each other. A1 verbs would be at the X along the x-axis and B2 along the y-axis. If we had a perfect correlation here, all verbs would be plotted along the diagonal through the middle, right? That would give us an R value of 1. We don't have that. It's lower than that. It's actually not low. It's still a clearly, it's not a random distribution here, but we don't have a lot of verbs along the diagonal. We have a few here, but not the majority of verbs. We do have a higher number of verbs above the diagonal. So the verbs that are plotted above the diagonal would be used comparatively more frequently in whatever is plotted along the y-axis. So more frequently in B2 than in A1 and vice versa. So what we see here is we have a lot more going on in the top right-hand corner of the plot, right? Which means yeah, this VAC is a lot more productive at B2 than at A1 level. If we compare 2 adjacent levels, B2 and B1, the R value is higher, 0.7, and we have a higher number of verbs on or near the diagonal, which are used roughly evenly in both corpora. So the productivity of this VAC is fairly comparable at both of these levels. I also wanted to see how if learners move closer to a native usage norm, and again, I'm using COCA here, as they move up in proficiency, and they do, essentially the correlation values go up we can get back to this, but I want to make sure I have time to talk about the last set of findings. And then the database also allows us to look at verbs in constructions more qualitatively. So here you see the top 20 verbs across levels in the transitive construction. Have is shared as the number one verb. We find some erroneously tagged German words in here. And then other than that, lots of short high frequency verbs at the lower levels in this construction, and more complex and lower frequency verbs at the B2 and C1 levels. Okay, finally, a few results on research question 4. That was the question about the role of formulaic sequences in second language construction acquisition. We get access to formulaic sequences through verb clusters, and I mentioned we used the top 50 verbs. They're listed here, and I also mentioned that we're looking at forms of the verb make, and focus on the use of formulaic sequences compared to variable or productive patterns around forms of the verb make, and the use of anidiomatic phrases in these cluster lists. So we first looked at frequency sorted cluster lists like the ones you see here, and observed development from a small number of fixed chunks to more variable and flexible items. So you could say learners are moving from fixed phrases to variable constructions, while they, at the A1 and A2 levels, they may only use make a decision and always use it as a fixed phrase, make a decision. They still use that phrase at the higher proficiency levels, but they vary the phrase, so it becomes more flexible. A learner would not just say make a decision, but also made a decision, or make a difficult decision, make certain decisions. So there's morphological variation, there are additional adjectives inserted, things like that, make the right decision, right? So that shows, and this we were able to see through the qualitative manual analysis of n-gram lists around those high frequency verbs. We see a trend or a movement from fixed phrases to variable constructions. We also looked at unidiomatic and ungrammatical uses of make, and what we found there, you see we couldn't find any unidiomatic phrases in the n-gram lists at the German B1 and B2 level. We see those unidiomatic uses, especially at lower levels, and more in L1 Spanish than the L1 German data. And very often we have overextensions of the verb make, where it would have been more idiomatic to use do or have. So a lot of them, you wouldn't say make a party, right? Have a party, or host a party maybe. Make a break, take a break. That's probably what they mean. But a lot of these unidiomatic chunks or constructions around make are the result of L1 transfers. So in German, it's perfectly appropriate to say, make holiday, Urlaub machen, you make holiday. Urlaub is holiday and machen make. So that is the way to say it. Same with laundry, make laundry, or make the dishes, not do the dishes, although in English, make the dishes might mean something different. So, and then same in Spanish, there were some transfer errors here. So, hacer una fiesta, make a party, which is not what we would use in English, right? So to sum up, what have I found so far? And this is, you can tell, there I have a lot more data to look at, and this is clearly ongoing research. But the initial observations, I think, are interesting and help us better understand how learner construction, the learner's construction repertoire develops. So one observation, so far in the previous study, we had only looked at L1 usage and advanced learners. What this study has shown is that learners, even at low proficiency levels, appear to have constructional knowledge. So the verbs they use in constructions are not randomly selected. They know what some of the good core verbs are that fit a construction. Of course, this knowledge is not the same across proficiency levels. So VAC types and verb-VAC associations differ across levels. We saw an increase in the range of constructions with a strong reliance of copula B constructions at the lowest proficiency level. We saw an increase in the number of verb types in a construction, so construction that is used consistently across proficiency levels, changes in verb form, in the verb forms it accommodates and that are used frequently in it. And in this context, we saw more low frequency verbs in constructions at high levels where there's a reliance on just a small set of high frequency verbs at the A1 level. So, but looking at correlations between learner data sets with L1 corpora, we were also able to see that the verb selections from the beginning to the advanced levels move closer to L1 usage. So learners are very much aware of or inspired by usage. So this whole study would very much support a usage-based approach to language acquisition. And then on the fourth research question, it's what I just discussed at the end here, is that we see that initially we have a fixed set of verb patterns, often unidiomatic chunks that are used around high frequency verbs at the low levels, which gives way to a more varied repertoire of flexible and more idiomatic phrases at higher levels. And this is interesting because it very much confirms earlier findings that were based on smaller data sets of just based on learner data produced by 1 or 2 learners. Okay, so what my goal in this talk really was to illustrate the power of taking a usage-based approach to second language acquisition and using learner corpora, especially learner corpora that track learners over time or across proficiency levels. And I would argue that learner corpus data can provide important insights into learner knowledge of constructions and the process of second language acquisition. And also that these findings are relevant for both SLA theory and pedagogical practice. At the same time, there's a lot more for us to do. So I'm still going to be working on looking at the constructicon of these L2 learners, L1 German and L1 Spanish across time. And I'll continue this combination of more quantitative analyses and more qualitative zooming in, because I would not just want to know what's the correlation score, but also, and how does that develop, but also what verbs to actually contribute to that. So I think finding a balance of quantitative and qualitative analyses here is important for us to have a better understanding of the process of acquisition. And I think maybe flipping things around, I've started from constructions and looked at verbs so far, but maybe looking at high frequency verbs to trace their argument structure developments across levels would be interesting to see how sets of constructions develop around specific high frequency verbs. Looking at L1 German versus L1 Spanish will allow me to see potential cross-linguistic transfer effects and differences that we need to pay attention to as we teach or as we work with learners from different L1 backgrounds. And then one thing that's always tricky in learner corpus analysis is the task effects, right? So how much is what I see in the data a reflection of the writing prompts and the writing tasks? We have a lot of prompts in here, so a lot of it should be already kind of evened out through the number of tasks, and the prompts or the text types produced at each level are comparable to some extent. But of course, things you ask learners to write at the beginner level are different from an advanced level. So I have access to the prompts, and planning to look at the VACs in the prompts more systematically. And then finally, more in line with maybe a dynamic systems theory approach to language acquisition, it would be interesting to look at the development of individual learners, provided that there's enough information, enough data produced by individual learners in this database to see how individual differences, or what role individual differences play in this acquisition process. Okay, I'm going to stop here and thank you all for joining in, for listening.